Yes, work that out. So, here we go. I think it's, I know.
You're recording.
Okay, and this thing will go for about 30 minutes or so, and then you're going to have to do something else. We'll see what happens. Okay, problems. Where do we start? 26. Okay, 26. So, to start with, this is problem 26 on page 216. And so here we go. Oh, Mr. King.
Tipping down a little bit.
Okay. So we're going to launch a hot air balloon. And we know a few things. We know the velocity of this thing, which is what? How fast is it going up?
20 feet per second.
Okay, 20 feet per second. And shall we call this the y-axis? So this is going to be dy dt. Questions on that? Now we're going to be how many meters away?
300 feet.
300 feet. Okay? 300 feet away. Now that's a fixed number. That's not varying. So we don't have to use a variable there. Now, what's going to be happening here is we're going to be looking higher and higher as this thing goes up. And so this is going to be called theta. And what else do we have here?
400 feet.
400.
It's at 400 feet.
Okay, how come it's at 400 feet? Does it tell you?
Yeah.
20 seconds later.
It's 20 seconds later. So eventually, this is going to be at 400 feet. And at that moment, we would like to know how fast this angle is changing. What is the rate of change of this angle? So what we're going to do is try to find d theta dt. Now, we've never done that kind of stuff in terms of angle measurement. Okay? So, here we go. This is a tangent. So, we'll go here, tangent theta equals y over 300. Okay?
Why do you do the y? Why is it just y? Why can't you put 400 right away for us?
Okay, now, never put those numbers in until the end. Why? That was question 2. This thing, this 400 is changing constantly. And so at one point, after 20 seconds, I want to freeze it for just a moment. I'm going to freeze it here, and then I'm going to be 400 feet up, and at that point, I would like to know how fast this is changing. Okay? So that's why this number will keep changing, but at the moment we have this one, we'll freeze that number.
Is that because 300 is a fixed
That-
number?
yes,
So
this is a fixed
y
number.
is the denominator, it's already there.
Yes, it's already here. Yep. Okay, now I'm going to take the derivative of that, which is the secant squared theta d theta dt. Now, we're not going to be meeting before the test, at least not very long, so be careful with this chain rule stuff, okay? And this is going to turn into what? 1 over 300 dy dt. Correct? Okay, now notice. That's interesting. This 400 never comes into play in terms of this stage because there's no y here. Okay? It's going to come into play in some other way to get another bit of information. Okay, now, so we have this. And now, I want to find the theta dt all by itself is equal to 1 over 300 secant squared theta, and then up here is dy dt. Okay? Now, that number is 20, so this is going to be a 20 up here, and the bottom is going to be a 300 down here. But what in the world is a secant squared of theta? Well, that's equal to 1 over Excuse me, just,
Cosine.
yeah, one like this is in the bottom, so it's like cosine theta, squared theta. Okay, what is the value of the cosine of theta at that moment? Well, this side's 300, that side's 400, this side happens to be 500. Okay, and the cosine is the adjacent over the hypotenuse, so this is going to be 300 over 500, or 3 over 5. But I don't want that here, because now this could be written this way if I liked, squared. And I need the square of that. So this is going to be 200 times 9 over 300 times 25.
Why do you define the cosine?
Because it's SOHCAHTOA adjacent over hypotenuse.
So, what are you trying to define?
It's the opposite of secant squared.
Okay. Is your question why not do this one?
I just don't know what you're doing.
Okay. I know that I have a triangle, right triangle over here, and it happens to be a 3, 4, 5 right triangle. This side squared plus this side squared is equal to this side squared. So that's how I got this. Okay? And then, can I figure out what the cosine of theta, this is theta, and the cosine is equal to the adjacent over the hypotenuse, SOHCAHTOA. Okay? So, and that's what I have right here, and I can figure out its value, which is 3/5 squared. Yes?
Shouldn't you find the cosine of 3/5 and square that instead of just squaring 3/5?
Once again, Greg, say it once again.
Shouldn't you find the cosine of 3/5 and then square that instead of just taking 3/5 squared?
Okay, now, I think I did what you said I should do, and we've got a little confusion there. We know that the cosine theta equals 3 over 5. So if I'd square both sides like this, then I have the cosine squared of theta. Now, do you have a follow-up question on that? Okay, because, thanks for asking though. Yes?
Way back at the beginning where you found tangent theta is 400 over 300, can't you just do inverse to get theta? And then use that later?
You could have,
Yeah.
but I haven't taught you that yet. Not until later on today, if I have time.
Okay.
So no,
We can't do it that way?
I would rather not.
Oh.
Did you use 1 over 1 plus x squared?
No.
Okay. No, we should do it this way. Next question.
31.
Okay, 31 in the same group. This is that boat tied in there, right? Okay.
I've got a question before we start that. Is there going to be a pool, like one like number 13 on the test?
Is there going to be one like 13 on the test?
Pool.
13 on the test. No.
Okay, good.
The ones I'm going to give you on the test will be similar to the stuff we did. Now, the other day you asked me in class that 19 one. That one won't be asked either. Okay? There are other very nice ones, but the ones I'll ask you will only be tweaked a little bit from what
Can you
we've
give
looked
us
at.
a couple examples of like ones you put on the test, like today's assignment? Will that
Yep.
be-
Today's assignment.
So like
Yep.
the one that we just did.
Yeah.
That's good.
Yep. I expect you to know that. And also some of these graphs and then doing the tangents to them. Okay, we're looking at 31. Okay, so here we have it. Draw a picture. This is 5, I think. Are we catching a fish here or drawing a boat?
Drawing the fish in. What one are we doing?
31, yeah.
31, we're pulling the boat. Or no, yeah.
Okay. Okay, now this, guys, what is the, let's see here. This is going to be 5, so that's fixed. What letter would you like to use on this side?
X.
And what do you want to do over here?
W.
So it's W. Okay? Now, so we have this situation. Now, I do know what W dt is. What is that from the problem?
3 feet second.
Yep, that's going to be 3 feet per second. Okay? And how fast is the boat traveling when it is, and this is going to be equal to 10 pretty soon. Okay? When we're 10 feet away. Okay? And now, we have to decide what we're going to talk about in terms of, is this going to be a positive direction or a negative? And since the boat's coming this way,
It's gonna be negative.
we'll just make it negative, okay? Some of it's in your interpretation of the way things are happening, okay? Now, I would like to know what dx dt is. This is what I'm going to try to find,
You just gotta be-
okay? And we're doing triangles again. And so I know that this side squared plus this side squared equals that side squared. So w squared equals x squared plus 25. Okay? Now, after you're at that point, you should be pretty confident you know what you're doing. Because we can find dw dt, which we're going to try to, what you have over here, and here we get dx dt. Now, tomorrow, when we do the implicit differentiations, that's on Thursday, they will be in problem sets, not in terms of just doing finding derivatives, the implicit ones. Okay?
How do you find that first set? Like, how do you find that first, the dw dt though, exactly? You just,
Okay, we're going to find the derivative of this with respect to t. Okay?
Yeah.
So we're going to have that up here. So this is going to turn into 2w dw dt. This is going to turn into 2x dx dt, and the derivative of this is 0. Now the twos disappear, and I'm looking for dx dt. I'm looking for this, so I get here w times dw dt all over x is going to be my answer.
Wait, why did you do?
I just divided both sides by x. Okay? And so now I think I'll start crunching numbers. I think I'm, oh, I can't yet. I don't know how long, when this is 10, what is w going to be?
Square root of 125.
The square root of
125.
125.
because. this
Any
is-
questions? This side squared is 100, this side squared is 25, so I have this. Okay? So, w is the square root of 125 times a negative 3 feet per second all over x, which is 10. There's your answer.
Hello.
Now, at that point, we probably should spend just a moment to see if we've got units right. And this is going to be feet, and this is going to be feet squared on the inside, so it's just feet on the outside, and this is going to be feet per second. And so these cancel out, so it's going to be feet per second, so we're as happy as can be. Okay? Yes? 29.
Yeah, I got
Oh, okay. It's almost,
Diagram.
okay. I'm going to erase this one. And next one we're going to do is problem 29 and see what it looks like. 29. We're going to take a fish in.
water, and there's a fisherman reeling him in at 4 inches per second.
Okay, he's on the dock. That's why we get the height here of 12. The old fish is way over here. And the line is coming in like this. And we're reeling it in at what rate?
4 inches a second.
Okay, 4 inches per second. Now we have a problem. What's nice here is this is in feet and this is in inches. How do we want this thing to go? Feet or inches?
Inches.
Inches.
I think we're going to want to do feet because this is over here. You can do inches if you want. So this is 1/3 foot per second.
No.
Okay? Question on that?
Fractions.
And now we're reeling it in. So we want the fish to come towards us, and so I'll make that a negative. Okay? Then I know it's coming this way for me. Okay. And what else do we have here? Is 12 feet above, and find the horizontal speed. So we want to find this speed. How fast is that moving? What letter do we want here, Grant?
20 feet.
Yes, eventually. Well, what letter?
Oh,
That's varying.
X.
X, and I'll just put a 20 here. That's where we're going to look at it. 20 feet. Okay? Be careful for units. And what do you want this side to be?
W
A
again.
W. Where do you get W from?
It's a nice letter.
Yeah, I like it better than Z. Okay. So we get here W squared equals X squared plus 144. It's almost like the same problem we had just did. Okay? And now, I do know that this here is dW dt. Put those kind of notes here. That's going to be equal to negative 1/3 feet per second. Okay? Now, and this is what I want to find. dx dt. And that's what I want to find. I'm ready to roll. I'm going to want to know how long W is when this is 20. I'll figure that out in a moment. So this problem is very much like the other one. 2W dW dt equals 2x dx dt. That's 0. These are out of here. And I want to find this, so that's going to be alone. So we're going to have W dW dt all over x equals dx dt. Okay? You can take it the rest of the way, can't you? Yes?
You changed units between inches and feet, but do you even have to on this one? Because they're just gonna cross out at the end and leave you with what you want.
You don't know.
But you don't know that. Right?
I wouldn't play that dangerous. Because that might be the case where they're just canceling each other out along the way, but that's,
So
that
don't they
isn't,
have to do it? Because-
no, well, I'm not so sure. I'm not totally sure on that.
And then W, find W, put in X and 20.
Yes. That W is equal to the square root of 144 plus 400. Okay. Aaron.
Hiding from your camera.
Okay. Next question. Any other questions? Yes.
They have it for inches per second in the back of the book.
Okay.
So,
Then you convert it.
Back and
Convert it.
forth.
Just,
Mr. Cleaner,
yes.
how many exact problems are we gonna have, like using figures on the test?
I would say you have 5.
Isn't that gonna take us a really long time?
That's why we have a whole hour and a little bit to do it.
Oh my god.
Okay? Then I'm going to do something else. Okay? Does anybody have finding the derivative question?
Yeah.
Yep.
Let's do a couple of those before I do something else. Okay,
25 on page 220.
page 220,
25.
25. Okay, now that's d dx. Are you with me? Okay. This one is a little bit more than what I want in the test because it's a triple. There are 3 factors here. There's actually 2 here, but we can tie them together. And here's another one, and here's another. Okay, ready to get started? And I don't think I'll clean it up, but I'll get it going. we're going to start with the derivative of the first, which is a 2, times sine x square root of 3x minus 1, plus the derivative of that, which is cosine x times what's left, 2x times the square root of 3x minus 1. And then it's going to be plus, and I'll write it down here, the derivative of this, which is going to be 1/2 times 3, okay, just a second, 1/2 times 3x minus 1 to the negative 1/2 times 3 times 2x sine x. Now it needs to be a little bit cleaned up.
I don't get it.
Can't do 17.
Well, okay, where'd you get lost, Grant?
The second part of it, the plus cosine.
Here?
Yes.
Okay, now that's the second step because there are products. It's a product rule. So now we're using this factor. The derivative of the sine of x is cosine of x, and it's going to be times the rest. This and this.
So, can you say that again, what do you do with product rule when there's 3? Take the
First, derivative of the first one times what's left, then the second one.
times both of them?
Yes.
Derivative of the third times both of them?
Yes.
Oh.
Yep. And so then you have this, and I don't know if it turns out nice or not. I don't think it does.
You wouldn't have to win with like 3.
I'm not going to go 3. That's a
Can
little
you
bit
do
much.
17 then?
Pardon?
17.
17?
Yeah, just do that one.
Okay, 17. You have a question on this one yet? Okay, 17. Here we go.
Oh dear.
The derivative with respect to t of 5t squared sine t.
Is that product rule then?
Yes.
Right here. Product.
And then 5 is constant?
And 5 is a constant.
Can't you use the chain rule?
Yeah,
You have
this one you won't. You can't use a chain rule on this one.
Won't you have to use it eventually in it?
Pardon?
You have to use the chain rule in some part of it, don't you?
Some of them, if I have this x squared, yes. Or
Well, it's
2x plus
squared.
1 or something in there. But in this case, it's just a plain product rule. So it's this here, derivative of this first is 10t sine t. And then I'm going to take the derivative of that. So it's going to be plus cosine t. And then it's going to be times 5t squared. And I'm done.
You could, 22.
Grant has 22 that he wants to look at. 22?
Yeah.
Oh, Grant. You're getting to be kind of mischievous here, just looking at other kinds of problems and saying how they work. Watch how this one goes. It would be great for the test.
Oh, all right.
Here we go. Now, Grant, notice what I'm going to do with this problem. I'm going to write it 3t squared plus 1 all over 3t squared minus 1, and I'm going to put a 3 here instead of a minus 3.
Okay.
Notice what I did. I flipped this thing to get rid of that negative.
You can just do that?
That's one of the laws.
Okay.
Yep. Because, can you visualize what's happening there?
Yeah.
No.
Okay, you don't. Then let's do it this way. Negative 3 times 3t squared minus 1. This is supposed to be up at the top here. 3t squared plus 1. Okay, now, I can do this quite easily. This is like 3t squared minus 1 to the negative 3, all over 3t squared plus 1 to the negative 3. Well, if it's negative on the bottom, it becomes positive on the top, and that does it. I was going to do it differently, but I just flip them. Okay, now, this problem is relatively easy if you use natural logs. Otherwise, this thing could get kind of wild. So I'm going to use natural logs. And
3t squared ln.
The quotient rule and
okay, now we also have some discussion up here. We could use the quotient rule and the chain rule. Okay, we'll do that. Okay, this then becomes, we're not going to use logarithms. 3 times 3t squared plus 1. 3t squared minus 1 to the what? Second. Okay, now that's this part, and now I have to take low-d high and high-d low. Okay? Okay, low-d high, which is 3t squared minus 1 times 6t. Oh, that's all. Minus 3t squared plus 1 times 6t all over 3t squared minus 1 squared.
That's disgusting.
Cancel a 3t minus.
Okay, now that's all right. It can be cleaned up a little bit. I was thinking I was going to do natural logarithm, but
Can you
cancel
shorter or easier, or does it clean it up more? Or?
it'll look a little different. Maybe it's cleaned up a little bit more.
Would you accept that?
Okay, did what?
It's just 0. You have 3t squared minus 1 times 6t, and then you have that minus itself.
This here?
Yeah, the top is 0.
No, I don't think
One's
so.
minus and one's plus.
This is plus, and this is minus.
You can do that.
Okay, but now that just makes me want to do something here. Xt like this, and this is going to be 3t squared minus 1 minus 3t squared minus 1. Like this. What?
Yeah.
Just minus.
Minus here. That gives a minus, and that's a minus. So this whole thing becomes a minus 2. And so this turns out to be a minus 12t all over. Notice these are together.
Yeah. Maybe.
And I'm just going to stop at that. Yes.
So would you accept that?
Yes.
Okay.
As our final answer.
I think so.
Oh, that's awesome.
Okay. Now, the next thing I want to do is this. What's that?
Can you do 27?
27 on this page?
Yeah.
Okay, here we go. This is going to be the last one I'm going to do. D dx of x ln of x squared out here. I do that when I do these problems so I can appreciate it a little easier. Otherwise, I'm going to get confused with where it belongs. Okay? I do the same thing when I have a sine. Sine squares. I put them out here when I'm working. This is a product rule. Okay? First, what's let me go the other way first. The derivative of this times this. This is easier, and I'll put that. Okay, that's first. Plus. Now, what's the derivative of that? It's going to be x times, what's this derivative?
1 over x.
2 ln of x, 1 over x. Like that. Okay, we'll just take this. Just this part. That's going to be 2 out in front, 2 ln of x to the first. Like that. And then the chain rule on the inside is 1 over x. And now we have an x up here. So now I would expect you to cancel that like that.
So you're like f of x would be ln of x, and your g of x would be like u squared or whatever.
So from the beginning,
No. This isn't a composite. This is just a product. Or are you talking about the second one?
Chain.
This is chain rule.
Yeah.
That is. Yes.
So you gotta find an inside and an outside function, right?
Yes.
Yeah, so your outside function is your, just the square.
From the beginning, can you put the 2 in front of the ln and start out that way or no?
Which I did over here.
Yeah. So that's what I'm asking. Can you put that 2 in front of the ln?
Oh, no. Now, hey, listen to this statement. I'm going to go a different color so you don't get confused. If this thing would have been written this way, then what we would have done is dump this out in front right over here like that.
Okay, after you.
See, and what is this one's derivative now? 2 over x. Okay? Okay. What I'd like to do next is figure out what the inverse, the cosine inverse of x, what that one's derivative is. Yes?
What proofs do we need to know for the test?
ln b and b of x,
Can you,
or ln x.
Okay, what is your question?
what proofs do we need to know for the test? Like on Thursday, do we need to know any proofs?
Yes.
Which one?
Which they're on that review sheet.
When did you show us the 1 over x?
Can you do that, the derivative of ln of x, that proof?
This was one of them, what I had on your list. Okay, what?
ln of x equals 1 over x.
Yeah, that one.
Okay.
Yeah.
So in that one goes this way. Ln of x equals y. See that? Okay, so now this is going to be e. So now I'm going to take it out of there, and that's going to be e to the y equals x. With me?
Yes.
Okay, what's the derivative of this thing? And by the way, what are we looking for? We're looking for dy dx in this case. Okay? So this is going to be e to the y times what?
Y dx.
And the derivative of that is equal to?
1.
Okay? So dy dx equals 1 over e to the y,
Which is equal to x.
which is equal to x. Done.
And the other one?
Okay.
Question.
Yeah.
How do you get from how do you get to the first step there?
Here?
Yeah.
Out of my head.
Yeah, but I mean, what did you do?
Oh, I just took this here and made it equal to y.
Oh, alright.
Okay? In other words, I just took this statement right here and made it equal to something.
Okay.
So I could take it out of logarithms.
What
And it's one of my big friends right over here. Yes?
Could you do the b to the x, please?
Okay. You see, these don't take very long to do.
No, good one.
And here's the other one. We have b to the x, the derivative of that, is equal to what? Ln of b times b to the x, right? Okay, so now in this case, I'm going to say b to the x, oops, b to the x is equal to e ln of b to the x. Got that?
Yeah.
Okay, now that is equal to e to the x to the ln of b. Okay, so I'm going to make this equal to y. So I've done all that stuff, and now I'm here. Now to find the derivative of that. dy dx is equal to this thing, which is e to the x ln of b, times, and what's the derivative of this?
X ln b. Yeah.
Question on that?
Yeah.
And what, oh, what is the derivative of 2x?
2.
What is the ln of b times x is going to be?
ln b.
Okay. See, this derivative is 2. That's just a number. That's just a number. Okay, and what is this quantity right here?
b to the x.
Okay, so this is going to be b to the x times ln of b, and I'm done. Okay? Yes?
Back at your first step, we said b to the x is e to the ln b to the x.
Yep.
Is that just because?
No, it's not because. These two are inverse operations of each other. Okay. Will you watch this just a minute? I'm going to, I have a moment to tie this into something I was going to do today.
Okay.
Okay? And that's this. If I have f of inverse like this, like that, what is that equal to? That's going to be equal to x. Here's another thing. What happens if f and g are inverses of each other? If I have that, f of g at x is equal to what? These two are inverses of each other. is equal to x. You with me?
Not really.
Okay, here's the idea. If I'm walking this way, and then start walking the other way, and then make an inverse, I'm going to go the same way I started with. I'm going this way, and then you inverse of an inverse is same thing you guys started with. Okay? No, we start with an x.
Oh.
In other words, here's my little machine. Like this, my little function machine. And throw an x in here. This part of the function is f of x. Okay, so out comes that, and then I put another machine here which undoes whatever I had in here. This is a terrible machine. This is f inverse of x, like that. And if I put an x in here, I'm going to get an x back out. Okay?
Close enough.
Let me show you something else here, just a second. By the way, today I do not have time after class to talk to anyone. I have to be on the road. And so, look at this. I say f, hey, watch this. If f and g are inverses of each other, are you with me? Hey, at this point, I see a couple smiles, and I also know what I've done. You look at, here's a prime example.
Overloaded us.
No, you tuned me out. And why try to teach after
Can you be
tuned
here
out?
at like 7:15 tomorrow?
Nope,